From instant finality to peer-to-peer consensus, Algorand is pushing the boundaries of what's possible with blockchain. Join me as I explore the exciting world of Algorand blockchain with the CTO of Algorand Foundation. Towards the end, he drops a major alpha too that you definitely don't want to miss. So today I've got John Allen Woods joining me from the Algorand Foundation, CTO of Algorand Foundation. And recently I just found out he's actually also known as, I guess, Orange Man and Algorand Jesus. So we might need to dive into that a little bit. What's that all about? And how you doing today, John?
Yeah, I'm good. DB, so good to be here, man. Thanks so much for the opportunity. Huge fan of your work. You put out some actual journalism. I'm so a big fan of all your videos and what you're at. So thanks for having me, Dave. Yeah, the orange thing is funny. You know, I was at a debate actually, I think it was Coinage maybe, but I did this thing where you had to debate other cryptos, like other layer ones, other layer twos. And so I was chatting with the guys from Arbitrum, and I was kind of like going back and forth. And he started pulling out some statistics. He's kind of rattling off kind of numbers, sounded very, very good, of course. And then I kind of was mocking him a little bit, and I started pulling statistics out of my ass. And one of the things I said is that my mom has 4 oranges. And then that spawned a kind of very technically interesting meme coin, because I generally think meme coins, and I have no problem with them, just like smoking. Do it if you want. I don't do it anymore, so I have no big interest, but I generally think that they're just part of life. It's a casino, have fun. Yep. But I don't tend to kind of find them technically interesting. But the oranges one on Algorand is because what they've essentially done is you have to mine it. And so they've simulated mining by making transactions. And so you spam transactions, essentially, these kind of zero algo or, micro algo transactions. And the more of them you do, kind of that your hash rate kind of increases or whatever. And so I think it's kind of an interesting simulation of a Bitcoin style system using transactions on a proof of stake network. So of all the meme coins out there, it's my favorite.
Nice. Yeah. I see a lot of networks kind of doing stuff like that. It seems like a great stress test for the network as well. It's brought down some networks, not Algorand to my knowledge, but others. It is tested them a little too much.
Yeah. Algorand's got this really great flex at the moment, which is like, we've never had any downtime. Now, as a kind of a software engineer and a realist, things have downtime. Even the most robust production systems that I've worked on, and I worked in like central banks and places that have very robust systems. Over a couple of years, you're going to have a few hours downtime, even on Swift networks and other major serious production systems. And so when your software is not just running on a single computer you control or a cluster of computers that you can control, and instead it's running a globally decentralized network involving different countries, different qualities of internet, different qualities of electricity supply, in terms of stability. It's nearly impossible to maintain a perfect 100% uptime. And so it's something I like to flex about, because Algorand's had no downtime, unlike some networks I could name. But at the same time, I
think most of us know which ones you're speaking of.
I've been down a few times.
Yeah.
I've run out of fingers. I'm gonna have to use my toe. But at the same time, I suspect there will come a day where we have a blip. All systems do. I hope not, and we're going to certainly strive not to. But I don't want to fly too close to the sun, because then I'll get shredded if it ever happened to us.
Of course, makes sense. You got to be careful sometimes throwing those stones. I get it.
Exactly, because I don't want to end up in my glass house, when if anything happens. But I think it is a testament to, and there's other networks that have had very little to no downtime. I think Cardano's had none as well, actually. Yep. Certainly, as far as I can remember. And even you look at something like Bitcoin or Monero, the old proof of work networks, pretty robust, pretty reliable. But it's a testament to the engineering that goes into these things. I mean, we roll out releases, and so do those other projects relatively frequently. And every time you put new software out there, you're taking a little bit of a chance the computers upgrade, and you're hoping that everything's good. And so you're trying to push forward the state of the art whilst maintaining a reliable system. And I think reliability is just number one for me.
Awesome. Kind of want to dive into that in a little bit too. Let's kind of go back to the start here and tell everyone a little bit about yourself, your background and where you worked and your fields and all that.
Yeah, sure. So always had a love of computing since I was a small child, I grew up in the 80s. I'm 40 years old, so I was born in 84. Grew up in the 80s, early 90s. Computers were cool. It was the era of swapping discs, diskettes in the playground, and you could just copy games, and there was no copy protection and no
big
online
floppy
stuff.
disks. Yeah.
Yeah. And for me, actually, it was the 3¼ inch ones that were kind of in vogue when I was kind of at that age that I was messing with that. But I remember, the feeling of power when I went around to one of my buddy's house, and like his dad had a decent computer, like an IBM 386 or something, or 486, and like, you take the floppy disks and you're using command line tools like pkzip to like take the Doom folder and compress the WAD and you walk it home and you're like, wow, Doom is on this thing, and you put it into your computer at home and you try to unzip it and get it working, and when it finally comes up and the sound hits you and the colors hit you, you're like, man, computers are just amazing.
Yeah.
So just went from that kind of natural love of, as one of my buddies at work says, these wondrous boxes of sand, referring to the silicon, I guess, and went from that to kind of did a degree in computing, as I suppose you kind of naturally do if you're interested in it. And I really enjoyed university or college because it was just fun, and I was learning a bit more about computers. And then just kind of had a career that spanned software and finance. My dad was a big kind of finance guy, and so he pulled me into little internships here and there, so I experienced some of that and spent some time working in banks. But also overall really has spent a lot of time in software engineering. As you kind of mature, if you wish to kind of move away from software engineering, you kind of do software architecture, designing the systems, so less code, more kind of words. And then towards the latter half of my career, I guess in my 30s, started getting quite heavy into cryptography, mathematics, or the slice of math, because I wasn't very good at math in school, but the slice of math that is important for cryptography. And so, because to me, this kind of like intersection of like security, computers, the internet, it was like the sexiest thing to work on. A little bit like AI is very sexy now. I was like naturally drawn to it. The idea that I can use numbers, prime numbers, whatever, elliptic curves, to send secret messages between people. I mean, that just it was like spy shit, So I was like, I love this. And so I worked on Cardano, I guess, notably in terms of crypto stuff. Worked on Ethereum with Consensus, which is another big kind of crypto company. And then, most recently, of course, with the Algorand Foundation, where I've been for the last 2.5 years. Good times, great people, and really enjoying working on the project.
Awesome. Yeah. So let's kind of dive into that. Tell us about what's your 30-second Algorand elevator pitch.
Sure. So 30 seconds. Okay. Algorand is a layer 1 blockchain. It runs code. And so if you have an application that you want to build, and that application benefits from decentralized execution, that is, that you can run it in an environment where you can trust the output, and you benefit from a disintermediation or decentralized aspect to your application, you can come and run it on Algorand. It's a decentralized computer, and your code will sing, your application will sing, and it'll give your users a user experience that's similar to what they're used to running standard apps on their computer, because it is fast, secure, and reliable.
Awesome. Well done in 30 seconds too. Perfect. So let's dive into, because obviously there's so many layer 1s, even layer 2s, layer 3s, probably soon to be layer 4s and beyond.
Even I roll my eyes when I see another one.
Yeah, it's really quite crazy, but here we are anyways. What would you say the a couple differentiating factors are from Algorand to, let's just stick to other layer 1s?
Yeah, so we have this like big slide deck and we talk about all this kind of stuff, and I've got a formal answer to it. But for me, there's the coolest thing, like, because you can look at, there's so many different lenses and aspects. How does the data flow in the network? What is the transactions per second? All this kind of stuff. And Algorand's got pretty great metrics compared to all its peers, pretty much across the board.
Mm-hmm.
I would say that the two things I would just shout out about, if someone asked me like, why is your one better than all those other ones? Because they're basically all the same, aren't they? Answer: Algorand has instant finality. Now, that's not just like a flex to say, oh, look, our transactions like confirm fast or instantly, which they do, but it eliminates and removes entire classes of error from applications. Because you got to remember, like these L1s, these blockchains, they are just another component in your toolbox of software engineering things. They sit alongside databases and the library you use to build your front end. They're just a tool to establish and to build an application. And so the having instant finality means, as I said earlier, it eliminates classes of error. And so it eliminates the need to worry about transaction replays. On nearly every other blockchain, certainly every other one I know about, from Cardano, which is exceptionally well engineered, all the way to say something like Ethereum, which is also well engineered, but much older, you have this idea that like blocks plod along, next block in the blockchain, cool, at some cadence, the block time. For Ethereum, I don't know, I forget what it is, maybe 12 seconds or something. For Cardano, it's every, I don't know, 5 seconds or something or less. And so bang, 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 you're going. And sometimes you'll have this like little disagreement where like there's a disagreement in the network. And so you have this kind of like Hydra, two-headed snake thing. And so now you've got two blockchains and they've split from a common root, but they're kind of plodding along. And so this happens all the time. It's called, they sometimes call it a block height battle. They call it a short fork. They call it consensus fork. It can also be known as a block reorg in Monero as an example. But essentially what's happening there is you got these kind of competing chains, right? And so what happens is one of these will naturally die away based on the rules of consensus. And for Bitcoin, that's like one of them will get so long that everyone just ignores the other one and says the longest chain wins. And for things like Cardano, it might be some other rule about how they determine, which one of these kind of short forks wins. But the problem is, if you're on the wrong side of history, let's say you're on this fork and your transaction is unlucky enough to be in this kind of aborted chain, right? You have to replay it to get it back onto the main chain over here, right? So that we call that transaction orchestration or transaction replay. But if you're in a production environment and I've just sold you, an NFT, okay, like a monkey NFT or whatever, a bored ape or whatever, for like 200 grand. You might have sent the funds to me, okay, on another chain. I then instantaneously send the NFT to you. But if that transaction is included in one of these blocks, it's in one of these short forks, it'll just like it never happened. It just evaporates. And so I'll find that the NFT is back in my wallet, like I never sent it in the first place, even though I did. And so when you're building big production systems, you can't just kind of manually replay these things when this stuff happens, and it happens every few minutes. So what you have to do is you have to build in middleware and big heavy software to kind of watch the chain, watch for these reorgs, replay the transaction where appropriate. And this leads to a pain in the ass because more code, more complexity, and having instant finality on Algorand, which is, I think, it's secret sauce, right? It's the coolest piece about it. Having that means that you don't wait for any confirmations. When a transaction is done, when a transaction is in a block, that's it. It is final. It's final the second it hits a block. And that's why we call it instant finality, because it's instantly final the second it appears inside a block. And with that secret sauce, you get, of course, fast transactions. You can walk away and be sure that something is done the moment that you see it in a block. But also for enterprise-grade apps, for the type of people that we care about selling this stuff to, right? Because we're always talking about the adoption of crypto and when are the big banks and big institutions going to get involved, and governments and stuff. Governments don't want like a load of middleware that they have to watch and replay transactions. It's a pain in the ass. And so having instant finality is amazing. And the second thing I would say in a much shorter way is that we have great dev tools. We used to have shitty dev tools because, I said earlier, these things are like operating systems, like they're blockchains, they just run code. And so you got to express that code in business logic somehow. And so we call that, of course, programming applications. And people are used to doing it in JavaScript or TypeScript or Python and languages that they like. And so Algorand used to require you to learn this shitty language called Teal. I shouldn't say shitty. A very elegant assembly-like language for calling mnemonics directly within the AVM subcomponent. But ultimately, a pain in the ass if you're a newbie to come into this. You got to learn new language, new rules, new semantics. Yuck. And so we still have that. We've left it there because it's very low level, but we've replaced that as a canonical developer tool with great developer tools. And what do they look like? A command line interface to build, test, and deploy. Fantastic support for regular syntactically normal languages like Python and TypeScript, and a debugging experience that's straight out of like, VS Code, like super slick, line by line debugging, this kind of stuff. And so this lets normal people who don't have like degrees in like computer science in the 70s build apps for Algorand. And so I'm quite proud of what the team have achieved with that.
Awesome. Yeah. And I think that last point is so important, really, to bring us get to that mass adoption that everyone is looking for and hoping we're going to see soon, because it's still a really small space, especially when it comes to developers. I've seen statistics showing that there's only like 18,000 full-time Solidity developers in the space. And there's something like 28 million developers in the world working on a lot of the stuff that you mentioned, Python, Rust, Java, all that. And we need the tools that are going to just make it seamless for them to transfer over and start building in the Web3 space.
Totally, dude. And you know, Dave, what I'd say is, like, I long gave up on trying to convert people from like Web 2, which I don't even like the term, to Web 3. And so because I think it's just such a waste of time. Instead, what I would impart to someone who's interested in learning more about Web 3 or crypto is, just like there are many cool technologies out there, whether you're writing Bash script or you're writing C code or you're in Kotlin building an Android app, there's lots of different great ways to express yourself and to enjoy the art that is software engineering. And platforms like Algorand, Cardano, Ethereum, and others are just another platform on which you can run code. And so I like to think of them like operating systems. And so really what we should be doing is, I think, rather than slicing it down saying, hey, we got like, the crypto industry is only, say, 0.5% of the world's devs or whatever it is, just like remove that and be like, all software devs can use a decentralized platform like Algorand, and if their app requires it, because it has requirements, if their application requirements are that they do need this disintermediation component or this decentralization, or they benefit from having a trusted execution environment, or, for example, being able to cryptographically assure the provenance of some action, if that application they're building has that kind of slant on it, that those things are useful, look at blockchain, because it can make your application incredibly interesting and bring new features to it that maybe you hadn't even considered.
I like that. No, that makes sense. And yeah, great point.
Thanks, man.
So, and I know you brought up the scaling, security, all that as well. So there's obviously this debate right now in the space. It's been a debate going on for a while, but actually just came back up yesterday in an interview saw with two, I think Ryan Bergerman's and Justin Bond's, and it was Laura Shin's channel about the trilemma and whether or not it still exists or if it's been solved. And I know Algorand preaches that they have kind of solved the trilemma. So I'm curious to hear your thoughts on all this and where it's at.
Yeah. I think people don't stop to think about what the word solve means sometimes. It's like, solved. It's a funny word, really. It's like, is any solution perfect? I mean, like, I drive a Tesla. I really like it. I just got it. It's like, every time I get into it, I love it. I love the way I play the music. I love the way it feels when I press the accelerator. I like the way it brakes itself when I stop pressing on the accelerator. And I would say that it's the best car I've ever driven personally. But it's like, there are definitely engineering trade-offs in that vehicle. I can see them. I can see them when I look around the vehicle. I can see them in the design. I can see them in the weight of the batteries. I can see them in lots of different places. And so, have we solved what it is to build a vehicle? I don't know. I think we're always going to iterate forward. And so, when I hear solving the trilemma, I think, unless you're maximally fast, i.e., you're sending transactions at the speed of light, okay, and you're maximally decentralized, i.e., every person on Earth is running a node, and you're maximally stable, whatever the other one is, scalable. So, like, basically, you can meet intergalactic requirements for transaction or for transaction execution. I don't think anyone's really solved something fully. And so, what you'll find is, I think Algorand has functionally solved the trilemma, as in it's close enough to checking the boxes that you could say that. But I think in all systems, in all software, in all products, there's design choices. And when you twist this knob to make it super, super decentralized, which we're going to do, for example, coming up with peer-to-peer, so we're going to change how data flows in the network and make it like a spider web rather than being like Bitcoin, rather than being through relays. Another knob moves on its own, right? You make it more decentralized, you'll find the speed maybe comes down a little bit. Or you turn the speed up and then you'll find that it's not so reliable, as we've seen with, say, Solana, which is super fast in many ways, but has had, say, for example, issues falling over. And so, yeah, I don't think really we should stop striving for solving it and try to build platforms that are great to use. But if I had to pick one of those things, I think the trilemma is decentralization, isn't it? Security and then scalability. They're the
correct.
three.
Yes. Yeah. But some people have said it's now 4 points, and there's the liveness factor, which
Yeah, it's interesting.
It could
Yeah.
be.
Yeah, that's interesting. I would pick, if I had to sacrifice one of these things, every fucking time I'm sacrificing scalability. Because, leaving and focusing on decentralization and security. So I'd rather something that's slow, maybe what you might call Ethereum. It's slow and decentralized in a way, compared to its peers, maybe compared to Algorand, compared to others. But it is certainly, maybe it scales with L2s, but doesn't scale very well on its own. But it is decentralized and secure. And so for me, that's the raison d'etre of blockchain. If we're not checking those two boxes, you might as well go and build a centralized application on Amazon Web Services or Google Cloud, because they're great products and you can build super fast super fast software products on them. And so, yeah, if you lose decentralization and you lose the security, you've lost the soul of what we're trying to do in the first place. You should just stop running that blockchain and go somewhere else.
Yeah, no, great answer. And I'm 100% with you there. And we really don't have anything if we don't have the two, the security and the decentralization. And that's one thing that I really appreciate about Algorand's approach too, especially with having their native assets and the approach. It's a gradual approach to decentralization. Like you said, you're moving to peer-to-peer, which is going to be a big move. But
Sure.
it's a kind of sometimes a shame to see the way the industry has put so much focus on scalability when we almost don't need it right now. There's just probably less than 1% of blocks are actually used across a space. Yet we
Right.
have so much sacrifice in the security and decentralization areas.
Totally. And so like Algorand, right, does like 10,000. I'm just going to open up this thing to check what it's at right now. So it does 10,000 transactions a second. And right now it's at like 25 transactions a second. So like, we're not saturating the blocks, as you just said. The blocks are essentially, they've got lots of space in them, and they could have much more transactions. And so for me, someone mentioned yesterday on Twitter, hey, are we going to move to like 15,000 TPS or 20 or 30? And we could. There's things we could tweak, and knobs we could move, and dials we could touch, and we would get it to be faster and still stay functionally decentralized and still stay reliable if we put enough engineering time into it. But it's just the focus for us at the moment is to move towards an archetype of what blockchain should be. And so maximize decentralization, peer-to-peer, maximize security, our consensus incentives thing that's coming up, which I brushed over there, but it's basically, block rewards for producing blocks a la Bitcoin or a la Ethereum, which right now you don't get paid, wildly, I think. And this is something I don't think I've seen in any other blockchain.
Yeah, it's very unique to Algorand for sure.
Yeah, this like you don't get paid for consensus.
Yep.
You don't get rewarded for consensus. So these two things are coming up, and if you look at what they do, like I said, peer-to-peer is decentralization. It removes the need for any relays or the foundation being involved in any way, and consensus incentives maximizes security. The fees now go to the block producers. And we'll have an extra kind of a little stimulus that we're going to put in some extra algo from the foundation's treasury. We're going to put a chunk in to kind of kickstart the excitement around this, but eventually it will just be the fees when that money is distributed. And so, but again, it maximizes security. And so that's the two things we're focusing on, because we believe, and I think it's correct to say that we're scalable enough right now. Like we're meeting demand, and everyone is, all transactions go through essentially in a single block. Only in very exceptional times when it's very, very busy does anyone have to wait more than 2 seconds, so it's pretty good.
Yeah, for sure. So yeah, let's kind of stick on that path too, because with scalability, there's obviously the monolithic versus modular debate, which is very popular. It's all over the place. And where we're at kind of in the adoption curve with crypto, we're still pretty early on, obviously, and we don't have a ton of users. At any time, we could hit that tipping point where it becomes much larger. So I see there's definitely chains that are building to prepare for that, I guess would be a good way to say it. I'm a big fan of sharded chains. I think they're building for maybe what's to come if it were to come quickly. So what's Algorand's position on, I know you mentioned you can tweak things and ramp it up, and you're currently at 10,000 TPS, which is amazing. And I think it's actually been live tested to show that it's doing those numbers too.
Yeah, I think
theoretical.
The highest I've seen it in the last 6 months was like 9,800 or something. There's a little bit of overhead, because you got to remember the complexity of a transaction will change that. Like, so the 10,000 TPS number is if it's just payment transactions.
Yeah.
Whereas if you start executing contracts and stuff in a block, which are essentially also transactions, right? You have this application call transaction, which is like, run some code in a smart contract. That number will drop, right? It drops to 7 or 6,000 or whatever, because it's got to do more work. And it's so when we say 10,000, we're talking about payment transactions. I want to be honest about that. But yeah, we've seen times when it's been 9,000 plus in terms of payment transactions. And so when you say monolithic versus modular, what I think you're saying there is like the kind of like is that like the L2s scaling or the sharded approach as an architectural approach versus, say, for example, single node like Algorand with all data on it? That's what we mean by monolith, right?
Kind of. It seems the discussion or debate may actually be altering a little bit more to integrated modular versus outward modular, and saying that we see Solana's kind of even moving towards an L2 or network extensions, which they like to call them, which makes sense because they've been bashing L2s forever. But so yeah, it seems like the space for the monolithic chains are almost moving that direction. And so I'm curious on your thoughts if you see Algorand having to go to a side chain, dApp chain, layer 2 type model at some point.
So I don't know. I don't think so. I don't think so, but maybe. I guess is the answer. Maybe I'd start by saying sharding is cool as a kind of a computer science concept. But again, like I said, like you turn this dial and then another one moves on its own. And so the trade-off, of course, with sharding tends to be data availability. So it's like, if my node doesn't have everything and maybe what I want lives 3 hops away, I've got to kind of go and fetch that information, which is not like, doesn't mean that it's not a good solution. It's just another trade-off you got to consider. Yeah. So we don't love the idea of sharding. Not saying we'd never do it, but at the moment, we don't love it really. And so in terms of L2s, I've always felt like they were kind of a band-aid, or a bandage on what is a suboptimal architecture for the underlying layer 1. I feel like having a layer 1, like, Solana talks about, like, I don't mean to keep bringing them up, but they keep making themselves easy to pick on.
Yeah, they certainly do.
But they're talking about Firedancer, and they're talking about 1 million transactions a second. Like even Visa globally, I think at Christmas time does like 25,000 a second or something. So like it's just not needed. But let's pretend that it is needed. You then still end up bloating the chain by like 4 petabytes a year. So you'll need to have a private contract with Amazon to get the disk space, to run one of these nodes. And so what they've done is they've maximized throughput and sacrificed decentralization, because there'll end up being a handful of node validators. They'll cost millions of dollars a month to run the nodes, because they'll have like 42 trillion exabytes of RAM, and like they require yottabytes of hard disk space. And so,
Oh, is that what comes after petabytes?
Yeah. I think it's like peta, exa, yotta. But like, and so you move one good dial to make your transactions bananas, and then you end up losing something else. And so my view is I'm trying to get, or we're trying to get Algorand to the sweet spot, which is functionally and pragmatically good enough to do what it needs to do. And so I think that today, 10,000 TPS is enough. Today having a layer 1 that like has reasonable fees and has a reasonable block time and has, say, instant finality, which I was banging on about earlier on, which I think is great. There are things that make it that it's, check good enough, and it basically meets all of the business requirements that we need it to meet, and it solves problems for its end users. And so I would hope that we never, that we would scale out as the global internet, because look at it today, it's petabits or whatever of speed with the undersea cables between different countries. I mean, it wasn't like that in the 90s, right? And so, in 10 more years, 20 more years, the internet will get faster, data centers will have faster routers and switches and hubs and whatever. And so you'll end up probably with not gigabit to your home, but probably like 10 gig to your home or whatever. And so I'm hoping that we can kind of like ride the Moore's law and deliver a platform that at the layer 1 is fit for purpose at the layer 1 does not require some tack-on solution in order to meet reasonable demand. And so I used to, so I still do very much feel like L2s are a band-aid, but I have a more nuanced view because someone educated me. And so I would say they're a band-aid for scaling for transactions per second. If you're trying to like scale your TPS or scale your fees, I think you've blown it personally with an L2. But where they might be interesting to me is like app-specific things. And so I can absolutely get behind the notion that there might be an L2 that's very good at a particular thing, just like an application-specific integrated circuit. Like, just like we have certain technologies to do certain things that are dedicated, embedded devices that are just great at things. So AI is kind of a hot one that I think is interesting because Algorand smart contracts, the blocks are every 2.5 seconds. Like you don't have time to run an inference engine on an LLM in 2.5 seconds. And even if you could do that, it'd be too complicated to put it in the abstraction of the AVM, which is the Algorand virtual machine, or the ethereum virtual machine. And so I could see a world where L2s are used to, for example, run some inference in a decentralized way, as in use a ChatGPT if you like. That's what I mean by inference, in a kind of a decentralized way, or for example, maybe for peer-to-peer messaging, maybe you want to use your keys, your Algorand account or your Cardano account to kind of set up a secure pipeline between two people, and using, I don't know, the cryptography of the elliptic curve Diffie-Hellman or something, and then you've got a secure connection, and then maybe rather than post those messages to the chain, you can do some kind of L2 for like, routing messages. So those type of things, I think L2s might be interesting. But yeah, if you're using an L2 just generally for TPS scaling, I think you've blown it.
One thing that Algorand is focusing on, which is unique in the space, is quantum protection or quantum computing. Obviously something that is getting a lot more attention lately, and there's not a whole lot of blockchains that are putting focus on this. It's interesting that you guys are. So can you tell me a little bit about where you see this is going and Algorand's focus on it?
Certainly. And so I think the reason a lot of chains don't get involved with the quantum thing is like, it's just hard. It's there's like a handful of people on planet Earth that know how to build these things. The cryptography is super new, and it's very hard to understand. And so to give people a bit of a primer, the way it works is that like, we talk about like private key. People have heard that expression before. But in cryptocurrencies, what is a private key? And so, like if you look under the hood, like inside a private key, like what is that on the computer's hard disk? How does it look? And so the answer is it's and maybe you know this already, but it's 256 ones or zeros in a row. And so a valid private key is either 256 zeros, 256 ones, or something in between, some mixture. And when the computer is using it, it essentially treats it like a large decimal number. And so 256 bits allows you to express a number that's like, quadravigintillion or something, I think is what they call it. Like it's a bananas number, like it's a squillion, million, billion, right? And so what we do is, to get our receive address or our public key, people, when you want to receive any crypto, you give people your receive address. That's actually your public key. And what that is, if you look under the hood, like we described the private key as being a big number, it's a point on an elliptic curve. And we use the word elliptic curve a lot, but not a lot of folks know that it's basically just like a two-dimensional curve. It's a two-dimensional plot of points. And a public key is basically one of these points. It's an XY point, like you'd see in school, like on a Cartesian plane, like X and Y. And the XY coordinates are not small. They're again, huge numbers, but it's still just an XY point. And so it turns out quantum computers, what they can do is they can go from the point on the curve and reverse the process back to what's called the generator of the curve. And this essentially lets them find the private key. And so the reason that cryptocurrencies are secure is that it's a one-way process. You start with the private key, and if you know that, you can find your corresponding public key. But it's very important that you can't take the public key point and reverse back the process to get the private key number.
Yeah.
And so quantum computers have a bunch of different algorithms that they can run, harnessing the power of quantum superposition, so doing many things at once, essentially. And the one that kills modern cryptocurrencies is called Shor's algorithm. And so it's just a way to do what I just described, reverse the public key into a private key. And so we want to be ahead of the game on this. We're watching. I mean, I look at Apple add post-quantum primitives to iMessage, the blue bubbles on iPhone. I look at Google add it to Google Chrome. Okay, I look at OpenSSH, I look at OpenSSL. I mean, all these companies and code bases and open source projects are not adding this stuff for fun or to make life harder or more complicated. They're doing it because they see a credible threat and they don't want their project to be destroyed.
Yeah.
And so a quantum computer is not sitting in your friend's house. Of course, it's going to be in some government NSA basement, right? And they're not going to steal my 50K's worth of crypto. They're going to be going after some government aid. It's going to be to break the
Satoshi's wallet, maybe.
right, yeah, or maybe a secret key that's like a military target. But this is a looming threat, and we want to be ahead of the curve. And so there are 3 places you essentially need to add quantum security to make your blockchain quantum secure. Place number 1, the history of the chain needs to be secured, because that's all being done with old crypto, and we can't just throw it away. And so we say old as in like non-quantum crypto. And so we can't just throw it away. So you kind of got to go back and you got to wrap that in a kind of a quantum-proof bubble. And that's what we've done. We've done the history of the chain. It's quantum secure. And we call those technologies state proofs, but they basically sign the history of the chain, digitally sign the history of the chain with Falcon, which is a post-quantum lattice-based signature scheme. And so any transaction ever done on Algorand from now back to the Genesis is quantum secure. What we need to do, and no other chain has done this, by the way, and we have not done it either, but I've not seen any other chain do this. We need to have a post-quantum consensus mechanism. So we use the VRF, the verifiable random function cryptographic primitive, to do our consensus. It's the secret sauce inside the consensus algorithm. That needs to be upgraded from elliptic curves, because it uses elliptic curves right now, to some type of post-quantum VRF. Haven't done that yet. And the last thing, we need to change. You
guys have the co-creator of the VRF, so you guys have a good guy on your team to help with that.
Yeah, Silvio's pretty great. It's great to be able to call the guy who made it when you're trying to change it. The second thing, the last thing, the third thing is that we need a post-quantum signature scheme. So right now, when you sign a transaction on Algorand, you sign it with an elliptic curve. You don't sign it with a post-quantum key. And so we need to move that to post-quantum as well. So I would say, in summary, we care about it. We're nervous about it. We're watching developments, and so we take it very seriously as a credible threat. Next year, the focus is going to be on getting a post-quantum VRF and seeing how we can move things forward in terms of post-quantum securing consensus. No one else is really doing it, but I think we need to look at it. And what I found interesting was that I looked at Vitalik's post, and obviously Vitalik is hyper competent and smarter than me, but his thoughts on post-quantum was like, we'll be okay. We'll be able to sort it out. And we use hash functions everywhere. So, they're pretty good in a quantum context, and he's right. But like, it's more reactive. And I want to have a proactive approach where we are secure before the boogeyman arrives.
Yeah, no, I like that. I think that makes a lot of sense too. And you brought up some good points about how, and I was not aware that Apple started incorporating this, and Google, and they're just dealing with, like you said, messages or emails. We're talking about people's money here. That's right. I'd say a little bit more important in a way. And if you're really focused on that security aspect, which I think all chains should be, it seems like it's something that's definitely worthy to put some time and effort into.
Totally. And if you look at Apple's example, iMessage is a global messaging system that people depend upon. It's integrated with iCloud. It's got group messaging, editing messaging. You can send movies and images, and it's very rich. It's a rich messaging, modern messaging platform. It's being used at scale, like unprecedented level of scale. I mean, how many people have an iPhone? Like, I would say every second there's probably millions of iMessages sent. So these guys are not changing. Like, I would say every line of code they change in iMessage, they must agonize over. They must be meticulous about it. They don't want to have an outage. They don't want to break everyone's phone. And so if they're adding all of this, voodoo math to secure against quantum computers to such a production grade system, you can guarantee that they believe there's a credible threat here. And so we should too. And as you said, it's people's money.
Yeah, for sure. So obviously that's kind of on the roadmap, something you guys are looking into, which is great. What would you say are some of the biggest challenges that Algorand faces going forward?
So I think the changes that are coming up for consensus incentives, so rewarding people for producing blocks, and for peer-to-peer, which is changing how data flows in the Algorand network, person to person rather than through a kind of a managed relay node. They are two staggeringly serious changes. They're kind of like open heart surgery on the protocol. And so, not that I'm necessarily fearful of it, but they are challenges to roll them out successfully, to make sure that we have people engage in consensus, to make sure that we do so without the network having any downtime. And I think these are kind of, you know, pretty significant changes that we're putting out. I think as well, you know, the biggest challenge Algorand has is really not a technological one. If I'm being completely transparent with you, I feel like it's more a one of awareness. Like, we in the crypto zeitgeist, if you look at crypto Twitter right now, or crypto X, you know, there's some chains that are just like constantly being talked about, and we need people to realize the value proposition that Algorand is able to bring, and hopefully gain that kind of, maybe, do I say market share, or kind of like mind space, maybe is a better word.
Yeah.
You know, grow that mind space. I think that's probably our biggest challenge. It's not like the post quantum stuff per se or anything like that. It's really, how do we become super relevant and super on you know, at the forefront of people's minds when they choose a platform on which to build decentralized applications. And so we're working on that. You know, even right here, you know, speaking with your viewers, of course, Dave is fantastic for me and us. We're very excited to do it. But also, you know, we recently hired Mark Van Leberg, who's a gentleman who is now our CMO, our Chief Marketing Officer, and he's been doing some great work. We did a few ads, which some people liked, some people didn't like, but overall, they were very popular. And so,
yeah,
you know,
those were good. Great movie.
Yeah, we're starting to have some fun and grow the mind share, and so that to me is probably the biggest challenge over the next kind of 2 years.
Yeah, maybe a little controversial, like you said, probably made some people mad, but not nearly as mad as some got from a recent stunt by Near Protocol. So
yeah, that one was weird to me. I mean, I just didn't get it. Like, you know, I was looking through I messaged one of my colleagues and said, look, oh, Near's had a Twitter hack, and it happens, right? And like, as I was kind of reading down through the tweets that the person was putting out, or essentially it was obviously all managed, but like, it was weird. It was like calling people out on how they looked, and like, you know, it was like, you know, get the fuck out of here, guys. This is going nowhere. It just had a weird tone. I thought it was someone just trolling who had actually genuinely hacked. So I think plus points for convincing everyone you were actually hacked. I think that's pretty hard to do, because you got to be spicy enough that people are actually like, oh yeah, fuck, they're hacked. But negative points from me for just like such a cringe kind of like punchline. It was just like, what the hell? I don't know. Did the community at large, from what you've seen, think it was good, bad, or indifferent?
I'd say mostly, from what I've seen, and we had a Twitter space on this too, on the negative side, it obviously brought a ton of awareness and attention to Near, but
yeah, that's true.
In the space, when you see hacks and stuff like that on a daily basis, it's one of those things that you almost don't mess with. Yeah. And it's kind of hard to get behind it when you're faking something that we see all the time and is really detrimental to a lot of people in the space.
Right. Totally. I totally agree with you. It's like the last thing I want to be associated with. It's like, so, you know, especially as a blockchain, right? You want to be like so far away from that. So yeah, I mean, look, we've had people in our organization as well have their Twitter profiles. Like Stacy, the CEO of the Algorand Foundation, you know, I don't know, 6 months, 8 months ago, had her Twitter profile compromised. She wasn't using appropriate 2FA. We sorted that out, but so it happens, right? But it's definitely something that is not good optics.
Yeah. Taking a step back just a little bit, you were talking about the awareness, and it seems like that is the case in the space in general. For a lot of, there's so much amazing innovation going on in the crypto blockchain space, and a lot of it is really dominated by money, VCs, and these chains that I don't want to say they don't deserve it. It's just, there's a lot of manipulation going on that pushes attention in directions where maybe it shouldn't be. So how do you see that being overcome, especially with the L2 narrative, which you have a new L2 spinning up weekly and starting with a multi-billion-dollar valuation, and just, in my opinion, almost doing irreparable damage to the space?
So I agree with you. And by the way, this is a hard question, like, because you know, the post quantum stuff a lot easier for someone like me. But I agree with you. I find it disingenuous and bananas and silly and just like a circus when I hear that there's yet another L2 that's funded to the tune of like 50, 80 million, like as if it's Smarties. Like it's huge amounts of money. And so, of course, VCs are a free market kind of guy, and VCs are entitled to spend their money on whatever they want, in my view. But like, I just don't understand how they keep getting convinced and hoodwinked, I would say, into this stuff. And so, yeah, if you're a VC out there, here's a message: before you spend your money, sir, please do a technical deep dive or have someone do it for you, and come back with the value proposition. What is this new L2 actually doing? What is the value proposition? What is it going to do that cannot already be done on Solana or Cardano or Algorand or some other network? And if the answer to that is nothing, please do not waste your money.
Yeah, no, great answer. And on that point too, to kind of spin off on not the L2 narrative, but interoperability. This is a big one in the space right now too. And I know I've seen, I think, a recent discussion going back and forth between you and Charles about maybe something going on between Cardano and Algorand, which is amazing. How do you see the interoperability of the space moving forward?
Yeah, so of course, I used to work for Charles, and he's been a great mentor for me. And I wouldn't have the role now that I have if it wasn't for the time that I worked for Charles. And I very much enjoy his kind of like his views on the space, and I think he's brought a lot of value to the entire industry. And I think Cardano being EUTXO based is a very interesting accounting model on which to build a kind of a programmable blockchain. And yeah, I'm very grateful to him. I think he's a great guy. And so, he also recently joined DREC. So Cardano, IOHK or IOG, I should say, Input Output Global is what the company is now called. They are the company that engineered the Cardano blockchain. And Charles, along with IOG, has joined this DREC alliance that we have. And we can maybe talk about that briefly later. But it's great to see that it's just another example. Like DREC's about key recovery, but it's another example of industry participants coming together as partners. And like, objectively, one could say that prior, Charles has called out various participants in the industry. There's been friction between Cardano and Hedera, etc. But they've put that aside to be like, the interoperability is more important. It's more important that we kind of come together and make things better for the users at large, and making sure that the standards are strong and set and in a way that people don't get hurt. And it's lovely. It's great to see like just really mature participants coming together. And Algorand are proud to be part of that alliance, and it's got a whole bunch of other great people in it, from Ripple to Hashgraph to a whole bunch of folks. So it's really good. It's a great example though of interop. I think interop's important, and I think so because of the following two things. These networks, like these distributed networks, Algorand, Cardano, whatever, they are networks of social interaction and networks of value, right? It's people and fans of the network and fans of the platform, and it's the value that's locked on the platforms, the monetary value, the financial value. And so having those things siloed or constrained and cut off in islands of wealth and of social flows and social interactions, that is not a good thing. We are better, as the internet has proven, I would think, we are better when we are globally connected, generally speaking. We're better when we can trade between each other, when we have global trade, when we can move value, move money, send money abroad, be able to interact with people all over the world. It's great when you go on holidays to Australia and you can pull out an app and meet someone there, right? I mean, so these are good things. And so we need to do the same thing for crypto. We need to unsilo these islands of social and monetary value. And so I'm hot on it. And to speak directly to the Cardano piece, Charles has some very interesting ideas about Algorand and Cardano partnering and having a partner chain integration between the two. I think that they're really interesting ideas, and to be completely frank and give you the reality of it, we're setting up a call and we're gonna have a chat about it. I think it's scheduled next week or whatever. And so I'm just going to sit down with Charles, with Romain, Romain, who's the CTO at IOG, and on my side, bring in a couple of the architects that I have on my team, and just talk through what that would look like, what are the technical integrations, what's the business value, what's the value proposition for users, how would that affect either network if it would, which I don't think it would. Yeah, and just talk through it. And so I'm very excited to do it. I think it's definitely worth doing.
Awesome. Yeah, I love that. We definitely need to see a lot more of it in the space. Like you said, it's such a, everything is a separate island right now.
Right.
And we definitely need not really bridges, but just more connections, more teams working together to bring the space forward. And because there's so many amazing things going on in the space, that by putting some of the heads together and all these amazing technologies, it could really help push things forward. I love that.
Totally. And like, the transitivity of value is important, right? I mean, you know, the idea that like value, whether that's social or fiscal, is able to be transported. I think it's so critical. I mean, it just, to me, it intuitively makes sense that you'd want to work these things together. You know, I mean, very much like you can take a file off Linux and open it on a Mac, right? You can take a file off a Mac and open it on Windows. I mean, it's essential. It would be absurd to think that computers wouldn't talk to each other because they're not the same type. You know?
Yeah, for sure. So, and you guys just recently had a big event. You had your Decipher, right? Is it? Yeah.
Yeah, Decipher, yeah.
A few weeks ago. What would you say, and I know you've kind of touched on P2P as well as the consensus rewards. What is the one thing you would say you're most excited for in the near future for Algorand?
So at the end of this year, like first month of next year, in addition to the kind of protocol changes we described, we're also going to be rolling out Algokit 3, which is our next gen developer tool suite. It's like an iteration on the dev tools I mentioned earlier. And so in that, we are going to have just a sublime line-by-line debugging experience where you can like inspect variables. You know, you can, and folks are not software engineers, maybe this sounds a bit like nonsensical, but like, you know, when you're writing code, you got to make sure that you regularly got to find bugs. You got to make sure things work. And one of the core things you do when you're writing software is you kind of step through the code very carefully, inspect the values that are stored inside variables, and you are able to visualize and see how your code is performing. And so we are bringing like this line-by-line debugging experience. So it's going to be as great as the experience will be in a traditional software development environment. And on top of that, we are also going to be bringing visual debugging. And so this is the ability to watch a transaction flow through the network, like with colors and with the flow, literally kind of a visual diagram of how the transactions flow. And so it really brings Algorand's developer tools to the standard that Ethereum's were at, you know, a few years ago, when they had really just nailed it, right? Those tools for absolutely everything. And so we've gotten there now, we will be there by the end of this year. And I think at that point, developer tools are basically awesome.
Awesome. Yeah, I think having a solid developer experience is every bit as important as the user experience to get more people to build. And because the dApps and the applications are what are really going to bring more people into the space.
Totally. And look, you know, it's very clear to me that like, if you look at any great platform that's like proliferated, whether that's something as specific as Rust and cargo and how crates are handled and how libraries are handled and just the tour de force that is like the Rust community. It's now in the Linux kernel, and you know, it's just like the language has just exploded because it's just so great. It's a great experience. You write code in it, it's super robust. It's awesome. Then you look at something that people will be more familiar with, who are maybe not engineers, but like when you're building apps for iPhone or Mac, you're using Swift. Now, Apple used to have a language called Objective-C, and it was like a C language-like experience. The syntax or how you write it was quite terse. It was quite hard to read. There was lots of symbols that didn't really make a ton of sense to people who are new. And now Swift is like so much more expressive and easy, right? So Swift is their new language. I'm sure it cost them tens or hundreds of millions of dollars to assemble the team and build that language and get it to where it is today. But it's been worth that investment, because now if you want to pick up your iPhone and you want to build something, you can be 15 years old and you can figure it out, because it's super easy. They're breaking down the barriers linguistically in terms of the words you have to type to get the computer to do something, but also in terms of the overall experience of debugging and like, what is debugging? You know, how do I test things? What does a good app look like? How do I get my application into people's hands? And these are the things that we're now focused on. And so I'm very excited, because we've come so far. Like, I mean, like And by the way, just to be clear, I haven't written a line of this stuff. I mean, I've just had the idea and built the team, and but like, you know, really, it's other people who've done this. Alessandro and our partners at Maker have done a terrific job. To just call them out, but you know, it's producing these tools. To me, as you just said, is like hypercritical. If we don't have them, you can be as good as you like. You can have all of this TPS, everything else that we talked about, scalability, decentralization, solving trilemmas. You can have a charismatic leader who's out doing podcasts every week. But at the end of the day, if your platform, your operating system is a pain in the ass to write code for, and you can't realize any value from it, then you've blown it. And so it used to be the case that you were writing assembly language. If you wanted to add two numbers together, you'd say variable A, push it into the register. Variable B, push that into the register. You know, load the number in A, load the number in B, and now instruction add. It would be that like heavy. Whereas now you just say A plus B equals C, and it just does it, right? And so, and so it's critical. And I'm very proud of what the team have achieved.
Awesome. Yeah, you guys have so many great things going on, obviously, with that, the dev kits and P2P, which is going to be great for helping with decentralization and the consensus rewards. I love the direction you guys are moving towards.
Well, yeah, what I want to do is maybe you could host a session, Dave, because I trust you, with Justin Bonds. Let's get Justin Bonds on, because I want to, when this peer-to-peer is done, right? Because that's, you know, I gotta kind of check the box first, and I appreciate that.
Yeah, that's been one of his.
Yeah,
the relayers has been one of his sticking points, but he has acknowledged that he also likes the direction you're going.
Yeah, no, he's a fair guy. I think he's a fair guy. And so, like, let's try and get him on. Maybe come on your show, and we can just duke it out a little bit. But I'd love to see. What I'm most excited about. You asked me earlier what I'm most excited about. I forgot this, and I'm going to say it now. I'm most excited to see what the next criticism is. Because we'll have kind of, I think we'll have fixed all of the bad stuff. Everything that's left is basically good. You get rewarded. It's peer-to-peer. The decentralization is good. It scales well. The dev tools are good. They don't suck. And the logo looks cool. I mean, what more do you want?
Yep. Yeah. And great point, because people will always find something. So
yeah, there will be. No, there will be. I'm excited. I mean, I've been kind of thinking, what could it be? You know, what's next? You know,
yep.
I don't know. Maybe they want us to rebrand the name or something. I don't know.
No. Yeah, don't go doing that. That hasn't been worked out too well for some other projects. But I really appreciate your time today, John. This has been an amazing chat. I love what you guys are doing at the Algorand Foundation. Definitely a big fan of everything. Great UI, UX team. The community is super solid. Everything from the security, decentralization, scalability, it's all there. It's the awareness that's really holding back so many projects, definitely including Algorand. So hopefully we can get past that. And where can people find you?
Yeah, sure. So I'm on Twitter. My handle is, on X, I should say. And my handle is John Allen Woods. So at John Allen, ALAN Woods, all one word, of course. And then our website is up. We've got a great new website that people can check out, Algorand, and get involved. It's just algorand.co, algorand.co for co. So yeah, would love, if anyone wants to reach out, please reach out and we'll chat.
Perfect. Now, again, I appreciate your time today, John. Great chatting, and we'll talk again soon.
Dave, thanks so much. And by the way, you, with your terrific audience that you have and the great content you produce, are helping solve the final frontier for Algorand, which is this awareness. So I'm very grateful for the opportunity to come on and speak with you, speak with your listeners.
Happy I could help.